Good morning, good afternoon, good evening. The topic for tonight's discussion is to turn our attention to what is called the elasticity of demand. And when you hear the word elastic, what does that mean to you? If something's elastic, it means it does what? It stretches, good. So when we talk about the elasticity of demand or the elasticity of supply, we're thinking about a measure of how responsive the quantity is to a change in price. Highly elastic would mean there's a big quantity response. Inelastic means it doesn't stretch very much. It means a small amount of response. And it is the next logical step in understanding the interpretation of markets and the interaction of demand and supply, because we know if demand increases, price goes up, right, and quantity goes up, and if supply decreases, price goes up, quantity goes down. But the next logical question is, by how much does price change, or by how much does quantity change when there's a change in one of those variables? So just to review briefly, markets, we said, are the interaction of these two groups, buyers and sellers. Buyers want to pay zero, sellers want to get an infinite price. We build the models separately, as we've done, and we employ this assumption of ceteris paribus, building the model by looking at one factor at a time. Demand, we noted, is the schedule of the different quantities that the whole group of buyers are willing and able to purchase at different possible per unit prices. So demand is a schedule, or it's a graph, it's a curve, it's a whole series of data points, different quantities at different prices. And we read it horizontally because quantity is measured horizontally, and we note that the higher the price, the smaller the quantity demanded. The lower the price per unit relative to all other goods, the larger would be the quantity demanded. And that's called the first law of demand. By the way, there are only 3 laws in the entire science of economics, so it's pretty straightforward. In a similar manner, we said supply talks about the quantities that sellers are willing and able to bring to market at different possible per unit prices. We read it the same way we did with demand. It's the quantity response to a particular price. And then we overlaid the two functions to see how markets interact, the interaction between buyers and sellers. We noted that at any price above X marks the spot, which is called equilibrium, that there is a surplus. There's more being supplied than is being demanded at that per unit price. And we noted that competition between the sellers will cause that price to come down. A surplus means there's stuff left over in the marketplace. They thought they brought to market 1,100 units. They were only able to sell 300. And so that is called a surplus. And as we said, when that exists, competition between the sellers competing against each other drives price down. As price falls, also we noted that the quantity supplied gets smaller if the price is lower. The quantity demanded gets larger as the price comes down. So the surplus is being eliminated by this adjustment, but as long as you're above equilibrium, there's downward pressure on that price. In fact, there's a disequilibrium between the two groups. Their plans don't match up at those higher prices. In a similar manner, we noted if the price is below equilibrium, then the quantity demanded is beyond what the sellers are willing to bring to market, and that is called a shortage, and that would be unhappy buyers, people willing and able to pay the price, not able to get the good. We noted that once the sellers know there's a shortage, what can they do? They can raise price, good, which is what they always wanted to do, right? Sellers always wanted to raise price. If they have a shortage, they know some of those people are willing to pay more than the price that they were charging. And again, as the price is raised, they're willing to produce larger amounts, so quantity supplied is getting bigger. Buyers respond to higher prices by cutting back the amount they're buying, but as long as you're below that equilibrium, there's upward pressure on price due to competition between the buyers. Remember, when you go into Ralph's, you're competing against all the other people who might be buying the avocados. Y'all with me? You're in competition with other people who want the good, and it gets allocated when the market adjusts only to those people who are willing and able to pay the price. So we noted that the intersection of the two is this equilibrium price and quantity. It means that the plans of the two groups now match up. The rate of production, remember they're both per time period, the rate of production just matches the rate of consumption. The rate at which they're putting the avocados in the bin just matches the rate you guys are taking them out of the bin. And so once you've reached equilibrium, there's no, given this demand and supply curve, there's no incentive to raise or lower price. Sellers know if they raise price, they're going to end up with a surplus, and they have no incentive to lower price because they're able to sell what they're willing to produce at that $1 price. And so equilibrium means that it has inertia. It will not tend to change unless something changes, unless one of the fundamentals on one side or both sides of the market adjust. We noted that we can calculate the amount of money being spent by the buyers. It is the total revenue coming into sellers, and it is price per unit times quantity sold, or in this case, this area of $30. So we trace through at the very end what happens to price and quantity when you change the functions. And we said an increased demand would lead to a higher price and a larger quantity. And so that increased demand pulls forth more production by sellers, and the higher price allows them to be able to produce the additional units. If you increase the supply curve, again, it's always a rightward shift. That would mean sellers are now willing to sell larger amounts at each particular price. And as a consequence, the price would fall because there's more being supplied now at each price, and the quantity would increase in that way. And then I summarized at the very end this idea of market dynamics by pointing out that really it is demand that determines price. Demand interacting with this response curve is what determines all the prices out there that you end up having to pay. Or all the prices that the sellers believe they're able to receive based on what buyers are willing, in fact, to do. And so demand, as we said, pulls forth additional production as the demand increases. So we noted then that understanding those directions of change, we can use the model to look forward or to look backward. And we know that if it is, we know what causes an increase in price. It is either demand's increased or supplies decreased, or both have taken place. We know a decrease in price would be due to a decrease in demand or an increase in supply. Either of those would bring price down. So the first measure of responsiveness on these curves, on these graphs, would be the slope of the curve. If you look at these two curves, A and B, which shows a greater quantity response to a change in price? Quantity is measured horizontally, so think about the price change, and then think about the change in quantity demanded. In the case of A, price goes down, and there's some increase in quantity. But because this is a flatter curve, the same price decrease brings forth a much bigger increase in quantity. So your summary statement about slope would be the flatter the curve, the more responsive the function. And that would be true about demand or supply. The flatter the curve is, that means there's bigger quantity changes for each change in price. So the flatter the curve is, the more responsive buyers or sellers are in the marketplace. And the same thing would be true for the supply curve. I raise the price and the quantity supplied increases a little bit, but for the same change in price, the quantity supplied increases a lot. So the flatter the curve, the more responsive it is, and the more elastic it is in that sense. The problem with using slope as our measure of responsiveness is that slope is subject to changes in the specification of the units that are being measured, either on the horizontal or on the vertical. You get a job with a financial services company and they're going to be making a presentation to their investors, and your boss asks you to draw an Excel graph of the changes in price over time. And so in my example, I'm going to use the same graph, but suppose this is time on this axis and this is the price of the stock on this axis. So you plug it in and you tell Excel, draw a line graph and so forth, and it comes out and it looks like this. And you take it and show it to your manager about, well, this shows that over time the price of the stock has gone up. And she said, well, that's not impressive at all. That's not impressive at all. So she takes the same data, but instead of using this much distance as a year, she uses this much distance. Y'all with me? And instead of using this much distance as a change in price, she uses this much distance. So the exact same data will come out with a graph like the one on the left. They're both the same data sets. All I've done is change the unit of measure that's being presented. And she said the slide's only going to be up for 10 seconds, so basically you want it to be impressive to them. You can see, well, you can see the XYZ company's done relatively well over the last 10 years. Next slide. So what economists did is said, let's find a method of eliminating this bias of the units of measure. And instead of calculating the slope, which would actually be delta P over delta Q, we're going to calculate a ratio of quantity to price, but we're going to calculate it as the percentage change in quantity divided by the percentage change in price. So in your notes, and all the rest of the elasticities I talked about, quantity is always in the numerator. Y'all with me? No matter what we're measuring, quantity of X purchased or sold is always in the numerator of the calculation. And then the one we use most often is price elasticity, and there we're measuring the responsive quantity in the numerator to a particular percentage change in price in the denominator. A bigger response, what would happen to the ratio if it's a bigger response, if quantity response is bigger? What would happen to the size of the ratio? Quantity is the numerator, so a bigger quantity would be bigger number. Good. And so the larger that number is, the more responsive buyers are to price changes, or the same thing with sellers. The bigger that quantity change is for a given change in price, the bigger the number you're going to get, the bigger the ratio, and the more elastic demand is in that particular case. So the simple calculation of elasticity is called point price elasticity. And when you calculate a percentage change, normally you take the amount of the change, divide by where you started from. If I said to you the price went from $1 to $1.10, what was the percentage price increase? 10%. And you guys knew it right away, right? You didn't even have to think about it. $1 to $1.10, 10% increase. But the way you actually got that was to take the size of the price change, which is 10, divide it by the beginning price, which is $1, multiply by 100 to get it into a percentage calculation. So delta Q over Q in the numerator, delta P over P in the denominator, and there's the calculation you would in fact be making. Again, the problem with using the end point on a calculation over a price range is that depending on which way you go, from a lower price to a higher price or a higher price to a lower price, you're going to end up with different elasticity numbers because you're using different numbers as the base of the calculation. So for example, if at point A the price is $4 and you sell $1.20, and point B the price is $6 and you sell $80, higher price, smaller quantity, right? Then if you calculate it from A to B, you'd be calculating it as for the quantity. Oh, I went right to it. You'd be calculating it using point A as the reference point. And so you'd be dividing through by a price of 4 and by a quantity of 120. And so you'd get 0.66 as the ratio. But if you started at B and calculated the same range from B to A, then 6 would be your base point for price, and 80 would be your base quantity for the percentage change in quantity, and you'd get negative 1.5. And by the way, price elasticity is always negative. Price elasticity is always negative because the demand curve slopes downward. You guys with me? Right? If you raise price, quantity gets smaller. So that's a plus and a minus, gives you a minus. If you lower price, which is a minus, and then there's a positive change in quantity. So the elasticity is always negative for the demand function. So we're interested in the magnitude of the number. How big is the number? Well, the way to get around that problem is to calculate what's called arc elasticity or midpoint elasticity. And here, you see what I've done in the calculation. When I calculate the percentage change in quantity, I take the change in quantity, and then I take the midpoint of the two quantities. Q1 plus Q2 divided by 2 would be halfway between the two quantities. And I do the same thing for price. I take the actual change in price and divide by the midpoint of the price, P1 plus P2 divided by 2. So in that case, we would get negative 1 in either direction of the calculation, because the midpoint's the same. So the amount of quantity change is the same, the amount of price change is the same, the midpoints are the same in either direction. So that's called arc elasticity or midpoint elasticity. And that is the unbiased measure of elasticity. So anytime you're asked to calculate elasticity, use the midpoint formula. You guys with me? Normally I'll specify arc elasticity or midpoint, but that is the one you always want to use because that's the unbiased estimate of this relationship. So why do we care how responsive buyers are? Why does the seller care what the elasticity of demand is? Well, it turns out that if buyers are very responsive, meaning that the numerator, the quantity change, is bigger than the denominator, then the size of the number will be bigger than 1. If the numerator is 20% and the denominator is 10%, then the number would be negative 2. If the numerator is 50% and the denominator is 10%, it would be negative 5. As long as the numerator is bigger than the denominator, we get a number bigger than 1, and we call that elastic. We say demand is elastic, meaning they respond a lot. The reason it's important is that if demand is elastic, lowering price increases total revenue. If buyers respond by a lot when I lower my price, when I sell a lot more or more than the percentage reduction in price, then total revenue is going to go up. And so I'd want to know, as I think about my pricing strategies, do buyers respond a lot or not by very much? Because that's going to tell me something about the effect on revenue and eventually on profit. If the two percentages are the same, I raise price by 10%, I lose 10% of my sales. I lower price by 25%, I gain 25% of my sales. The number will always be 1 because the two percentages are the same. Numerator is quantity, denominator is price. If those two percentages are equal, the number will be negative 1. And that's called unitary elastic. Unitary meaning 1. And when demand is unitary elastic, it's a wash in either direction. I raise price by 10%, so I get 10% more money on what I sell, but I lose 10% of my sales, so total revenue doesn't change. I lower my price by 20%, so I'm giving up revenue to the people that are buying it, but I get 20% more sales, and so it's a wash in that case. Demand is unitary elastic. And then finally, as you would guess, when the quantity response is smaller than the percentage change in price, when the numerator is smaller than the denominator, the size of the ratio is less than 1. It's going to be a fraction. I raise price by 10%, that's the denominator. and I only lose 5% of my sales. So I would get negative 1/2 as the calculation. And it means buyers are not very responsive to changes in price. And we'll look at reasons why that, in fact, might be the case. Well, if demand is inelastic, then raising price increases total revenue. Raising price increases total revenue because I get the higher percentage change in price and I lose less than that in terms of lost sales. My example, I raise price by 10%, I only lose 5% of my sales. So I get more revenue by doing that in that particular way. So those are the three possible levels of elasticity that could be there. Greater than 1 means it's elastic. Lower price raises total revenue. Unitary, it's a wash. Percentages are the same. Demand's inelastic, it's a fraction, and raising price increases total revenue. On a straight line demand curve, it turns out that the upper half of the curve is the elastic region of the curve. The midpoint is unitary elastic, and the bottom half of the curve is the inelastic portion. If you remember my example of 10, 9, 8, I had $10 1 unit, $9 2 units, remember that one, and so forth. Well, think about it. If you're at the very top, I'm at $10, I sell 1. I lower my price to $9, I sell 2, and total revenue goes from $10 to $18. So that's the elastic range, right? They're doubling actually the quantity. For a 10% price reduction, they're doubling the quantity they're buying. And then if I lower it to 8, 3/8 are 24, so revenue's going up. Lower it to 7, 4 7s are 28. Lower it to 6, 6 5s are 30. That's the upper half of the curve. That's the elastic region. When I get to $6 and $5 and sell 5 shirts or 6 shirts, then the total revenue is the same. 5 times 6 or 6 times 5 is $30. And that's the midpoint, and that's what I said is unitary elastic, no change in total revenue. And then if you get below a price of $5, I sell more shirts. You know, quantity is going up, but total revenue is going down. I lower it to 4, and I sell 7. 4 7s are only 28, and I was getting 30, right, when I was charging $5, and it continues to go down. Now, because that's the case, you can use the slope to accurately depict an elastic or inelastic demand curve. Because if you look at A, extend that demand curve out to where it meets the axis, which would be all the way over here, you're on the upper half of the curve. Y'all with me? A is on the upper half of the curve. That's the elastic region. And so if you lower price, when that's the case, clearly total revenue goes up. So if you want to draw an elastic curve for purposes of looking at it to see what's going on, just draw it flatter than 45 degrees, and you'll have an accurate geometric representation of elastic. If you look at B and extend that line all the way up to where it meets the vertical axis, you're looking at the lower half of the curve, and that's the inelastic range of the curve. And there, at P0, I'm getting in this much revenue. Raise price to P1, total revenue goes up. So a very steep curve, more than 45 degrees, per a linear demand curve is inelastic. Flatter than 45 degrees is elastic. Lower price raises revenue when it's elastic. Raise price raises revenue when it's inelastic. Questions? So now, going back to this, how things change in the marketplace when demand shifts or supply changes and so forth, we can see that the elasticity is what drives the amount of price change or the amount of quantity change. Here I've drawn a very flat supply curve, meaning very elastic. Sellers will increase the production rate a lot for a small change in price. and I draw in a demand curve. It looks like it's a unitary elastic demand curve, and you can see what happens. Price goes up by a little bit, but quantity goes up by a lot because demand's elastic, because quantity adjusts a lot to that change in price. If supply is inelastic, meaning drawing it steeper, I draw in the same change in demand as we had before. But notice in this case, because supply doesn't change very much, I get a much bigger increase in, much bigger increase in price, going from this intersection up to the higher one, and a very small increase in quantity in that case. So if sellers don't respond very much, or saying it a different way, if it takes a big price increase to get them to produce more, that's when supply would be inelastic and you'd get a big price change and a small quantity change. I just did that. Oh. You do the same thing with changes in supply. Draw an elastic demand curve. Buyers are very responsive when there's a change in quantity. And so supply decreases and we get a small increase in price, but a large decrease in quantity. And again, it's because buyers respond a lot to changes in the supply. And then if I draw an inelastic demand curve, then in fact you can see the opposite's true. The same change in supply would cause a big increase in price because it takes a lot of price increase for buyers to be willing to cut back on the amount that they're in fact purchasing. So there is the definitions, elastic, unitary, inelastic. There are the graphs of that to portray it. And then we can see, as I said, what is the effect on price and quantity depending upon how responsive both sides of the market are to a change in price. So the next logical question is, what would make demand for a product very elastic? Or what would make it inelastic? And the same thing for supply. Well, the major factor that determines how much buyers respond to a change in price is the amount of information they have about the price change and about the availability of substitutes. If chewing gum goes from $1 to $1.25, do you cut back very much on how much gum you chew? No, and one of the reasons might be you might not even notice the price change, right? I mean, we don't look at all these prices all the time. You go to 7-Eleven, you grab a bunch of stuff, and you check out. So if you don't know about the price change, you're obviously not going to respond to it because you don't even know it's changed. And then secondly, if you don't know where the substitutes are, then you tend to be less responsive because you don't know what what you could substitute for. What is true about gasoline prices at gas stations that are right next to a freeway versus others? They're higher. And the reason is this exact point. The guy on the freeway, or the guy meaning whatever, the person on the freeway, when they pull off, often doesn't know where the substitutes are. They don't know that a mile up there's a Shell station, right? And their time value is probably high because they're traveling. So you tend to see gas stations charge higher prices because buyers are more inelastic because they don't have knowledge of where the substitutes in fact are. The second factor is how many substitutes are there, and that is the major determinant. Is a major determinant of how much you respond to changes in price. Gasoline prices jump around a lot. Do you change the amount you buy a lot when gas prices change? No. Good. So you're not very responsive, right? So we would say demand is inelastic, not very responsive. And the reason is that people don't consider public transportation to be a close substitute to driving their own car. When I teach at USC, I usually teach in the morning, and if I get on the 101 at 6:45 in Encino, I can get ahead of the massive group coming down the 170, and I can get down there in about 30 minutes. 15 minutes later, that massive group from the 170 is now in front of me, and then it takes like 45 minutes to an hour to get down. But the thing I always observe is, as I'm driving, and the roads are just packed, right, with all these steel cages, there's one person in each car. Y'all with me? Almost invariably, there's one person in each car. Occasionally, there's two people, which is probably a mistake or something, but almost everybody drives by themselves. And the reason is that if you drive yourself, when do you leave to go? Whenever you want to. And where do you go? Specifically where you want to go. And you can control the temperature, the humidity, the music, and the scent of the trip. Y'all with me? If you take a bus, when does it leave? 15 minutes after it's scheduled to, right? Where does it go? Someplace, which probably is not your building, right? And you cannot control the temperature, humidity, and scent of the trip. You can control the music now because everybody's got, pods or whatever they are. But what are they called? Oh, I know they're called earphones. There's another name for it. Earpods. See, there it is. That's +2 right there. See, Haley knows what they're called. Good. So that's the point. People don't find those to be close substitutes, and so consequently, demand is not very responsive to price changes for gasoline as a product. Now, what would be true about the elasticity of demand for the gasoline at a specific Shell station if they raised their price and other gas stations did not change price? Would they lose a lot of sales? Yes, because what's true? There's lots of close substitutes, right? There's lots of close substitutes. Number one, they're all rated by octane, right? So they're all the same octane rating. And if you buy regular, often they are from the same refinery because regular has no additives in it. The other one, the plus and the super, the companies have different additives, and so they come from different refineries. But they're very, very close substitutes. Are they identical? No, and that's a very good point. No, they're not identical. I mean, they're differences like maybe you have a really pleasant person to deal with, right? Who really understands how to run the cash register. And at this other place, I can't understand the guy, right? So that's a difference. Marketing people showed me a study about 10 years ago, and they were saying women prefer Shell over Mobil. And that actually is the intersection of White Oak and Burbank, and the argument went that the symbol for Mobil is what is the symbol for Mobil? No. The symbol. It's a flying horse called Pegasus, right? Good. And they used to have it up. They don't show it as much anymore, but they used to have it up. But it's this giant testosterone bird, right? I mean, just bulging muscles all over it, right? What's the symbol for Shell? It's a little shell. And at night, when it gets dark out, you can close the shell and you're safe, right? What are the color schemes? Mobil is what? No, Mobil. Yeah, blue and red trim with white. What's the color scheme for Shell? Yellow and red. Good, primarily yellow. Good. And yellow is thought to be much more attractive to women because it's a very warm color, right? So it's a warm color and you can close the shell at night and so forth. So I laughed, right? So I was filling up at the where? No, the Mobil, right? And I looked across at the Shell station, and there are all these women buying Shell. So now I go and buy Shell, right? So, but in any case, they're close substitutes, but they're not identical substitutes. So the more close substitutes there are, the more people would be responsive to a change in price. Take Domino's and Little Caesars. They're really close substitutes, right? So a rise in price would lead to a big a shift in quantity demanded. The third factor is the percentage of your income that you spend on a product. The bigger an item is in your budget, the more elastic demand tends to be. And the reason for that would be the bigger an item is, the more time I'm going to spend finding out about the relative prices and finding out about the substitutes, because it's a much bigger part of my income or whatever. If an item's like the chewing gum that I used before, and it goes from $1 to $1.25, it's such a small item in your budget, you probably don't chew any less gum at all, right? And that's a 25% price increase. If they raised tuition at Northridge by 25%, would there be a big quantity response?
Yes.
The answer is yes. Good. So the bigger an item is, the more elastic demand tends to be, and the smaller it is, the less elastic. My son has a website and commercial art company up in Santa Barbara, and he designs websites and he updates web pages and does logo design and brochures and banners and all kinds of stuff. So I was talking to him one night and I said, how do you price changing the page? How do you price updating a page on the website? And he said it's $50. And I said, but you have lots of different customers, right? And he does. And I said, here's what I recommend. Put up a pricing schedule of the following. It says, if you want a page updated, it's $50 and it's 5 to 7 business days. If you want it done in 2 days, it's an express and it's $100. If you want it done overnight, it's a super express and it's $200. Now, the reason is he has some clients like Mr. and Mrs. Johnson who run a fish store downtown, and they change the fish of the month picture once a month. And so that's a page change. But they can easily, and so that's a big part of their budget, this changing the page of their advertising budget. So they're the elastic demanders. But one of his other clients is Verizon. And the updates that they do are changes in their coverage maps. And Verizon, as you know, has a multi-million-dollar advertising budget. So the price of changing one page is infinitesimally small relative to their budget. And they're going to want it done overnight because it shows better coverage, right? They're expanding their coverage and they want that information out as soon as possible. So that's a great example of how to take advantage of knowing different elasticities and then be able to price accordingly. You all buy from Amazon, and I'm a VIP prime person. And so most of the stuff I get in 2 days with free shipping. But if you've ever looked at their shipping charges, the standard is probably free or something 5 to 7 days. If you want it in 2 days, it's like $8. If you want it overnight, it's like $100. If you want it the same day, it's like $125. But if you really want it the same day, you can get it the same day. You just have to pay $125 shipping cost. That's the inelastic demander. Guys with me? That's a person who's so anxious to get it that they're willing to pay. And those differences in price are not based on differences in cost. They're based on estimates of differences in elasticity of demand by various buyers. So, how much do I know about the price change? Knowledge of substitutes. How many substitutes are there? The more elastic. The percentage of income, the bigger it is, the more I'm going to know about alternatives. And finally, the period of time following a price change affects how much the quantity responds. That is such a strong relationship. Excuse me, would you mind putting your phone away and leave it away? Thank you. It's such a strong relationship, it's called the second law of demand. And it basically says the longer the period of time that the price change is in effect, the more people respond to the price change. The longer after the change in price, the more people respond to the change in price. And so the statement is demand is more elastic over a longer period of time. The reasons for that go back to the other determinants of demand. Over time, you're going to have more knowledge about a price change and about what are the available substitutes? Years ago, people only ate chicken as Southern fried chicken. That was about the only recipe people knew. And most of the meat consumed was beef or pork or whatever. Well, there was a big shortage of food. There was something, and the grain prices went up, and then beef prices went way up. And so people were looking for substitutes. Well, as I said, initially they knew about chicken, but they only had one recipe for it. But over time, all these magazines, Good Housekeeping and all those home magazines, came out with new recipes on how to fix chicken. There's the one where you make rice with cream of mushroom soup and put the chicken in, right? And there's all these other ways to cook chicken. So the more knowledge you had over time, the more people substituted chicken for beef. Secondly, over time, there tend to be more substitutes available. In 1979, OPEC raised price of oil and therefore gasoline substantially, and there were price controls in the United States, which led to shortages at various gas stations, and you had to at one point in California they actually had odd even days, so the last number of your license plate was even, you could shop on Tuesday, Thursday, and Saturday. If it was odd, you could shop on Monday, Wednesday, Friday, and then Sunday was reserved for commercial vehicles. And a lot of people got got the placard for commercial vehicles. But when that price change happened, there was a big increased demand for alternative forms of transportation. And that was the beginning of the investment in the hybrid concept of the combination electric motors and gas motors. Initially, the hybrids were horrible because the electric engines were so bad that they didn't have any power at all. And so they weren't a close substitute. But over time, as you know, technology's changed, and then gas prices went back up again, stimulating more and more hybrids being produced. And then they had a breakthrough with the electric motors, so now the hybrid is actually faster than a gasoline engine. It's got this amazing, I don't know, it's 0 to 60 in 2.6 seconds or something like that. I mean, pushes you back in the chair. Good. More substitutes over time means a bigger response. Third, over time, you have a chance to change the complementary package of goods that you own. If you have an SUV that has on a lease and it has 1 year left and gas prices go to $6 a gallon, you will probably cut back some in your driving. But you may not cancel the lease because there's a big penalty. But think about it. After the year has passed and that lease expires, what characteristic will you look for in a new vehicle? Lower miles per gallon. Higher miles per gallon. Good. When you make that change, then the quantity of gasoline purchased would go down by even more. Everybody see it? Over the long term, you have a chance to change that complementary good. There are people that drive from Thousand Oaks to downtown LA every day commuting. And it's like a 2-hour commute. And that's each way. And they do it. But I guarantee you, and they're not likely to sell their house if gasoline goes up to $5 a gallon or whatever. But over time, as people, as you graduate and people get new jobs, they will look much more carefully at the distance between home and work. Y'all with me? If gasoline prices go up, over time, people would want to locate closer to where they're in fact working. And when they do that, then their consumption of gasoline will go down by a larger amount. So the longer the period of time, the more responsive buyers are to changes in price. Now, there's some other elasticities that we use to measure the effect on quantity purchased of other things. Where is it? No, I'm looking for my watch. Good. There are other elasticities to measure the effect of other things changing on the amount sold of a particular product. And the first is measuring what's called the income elasticity of demand. meaning how sensitive is demand to changes in income. And again, as I pointed out to you before, the numerator is always percentage change in quantity of X. That's the one you're looking at, right? The denominator in this would be the percentage change in income. And it's a ratio, obviously. The bigger the ratio, the higher the income elasticity of demand. For normal goods, it would be a positive relationship. For normal goods, when income goes up, you buy more. So the sign of the relationship would be positive. Some examples of estimates of that: demand for clothing is close to unitary elastic. A 10% increase in income leads to about a 9.5% increase in consumption. Stereo units are very responsive to income changes over certain ranges. And a 10% increase in income may lead to close to a 30% increase in expenditures on quality units. Not number of stereos or TVs, but the quality units that you're willing to buy. Quantity or quality. And then obviously inferior goods, it's a negative relationship. Income goes up, you buy less of that particular product. Did I talk about Starbucks? No? Income elasticity? Well, Starbucks is a superior or normal good. I'm sure I talked about this before. And they're very concerned about changes in income because their sales are very sensitive to that. And we noted that what they want to do is locate their stores where incomes are rising. And as I pointed out, in China, incomes have been going up dramatically. And so Starbucks, and I just read a couple days ago, Starbucks currently has 500 locations in China, and they're going to open 500 more this year, both in construction and plants. But they're going to double the number of outlets because of the rising incomes in China. Firms are interested in how sensitive are my sales to changes in my competitors' prices or changes in complementary prices. And so here I want to look at the cross-price elasticity, meaning the percentage change in the quantity of my goods sold in response to the percentage change in the price of some other good. And it could be a complement or a substitute. The closer the complement, the bigger that ratio would be. The more my sales would be responding to changes in my competitor's price. And for substitutes, it would be positive, right? If they raise price, I sell more. If they lower price, I lose sales. For complements, it would be an inverse relationship. As the complement goes up in price, I would lose sales, so it's a negative relationship between the two. Cross-price elasticity is used for many different things. One is, as I said, the magnitude tells me who are my closest complements or my closest substitutes. Smucker's bought Jif peanut butter because they looked at which one was the strongest complement to their particular product. And Jif has a higher quality than some of the other brands, and Smucker's obviously has a higher quality. So they looked at cross-price elasticity there. Pepsi-Cola bought Fritos as complements, and the same thing was true. They looked at all the different kinds of chips, and Fritos had the closest cross-price elasticity. Courts also use cross-price elasticity as a measurement of market power or monopoly power of the firm. If somebody else lowers their price and I don't lose much of my sales, it means that my product is considered substantially different from theirs, and I have more market power in that particular case.